So welcome everybody. My name is Johnny Gabriel and I'm moderating today's session. I'd like to welcome Jeff Underwood and Rui Frajão, our speakers for today, who will be telling us about the latest innovations in accelerating network lifecycle for 5G. Our first speaker will be Rui Frajão. He is the Chief Technology Officer and Executive Vice President of Product at B-Yond. Rui joined B-Yond after a successful exit as CTO at Vasona Networks, an innovative provider of multi-access edge computing solutions. Prior to that, Rui spent 15 years at Vodafone, including a role as Director of Network Engineering, overseeing network operations across Germany, Netherlands, Hungary, Czech Republic. Also, we have Jeff Underwood with us here today. He is the Senior Solutions Manager for KEYSIGHT Technologies. Jeff is responsible for architecting and developing solutions within KEYSIGHT and with partners to solve service provider challenges. Jeff came to KEYSIGHT from Ixia, where he was the Vice President of Sales for Strategic Accounts, and has delivered solutions to operators in the US and the Asia markets. The main topic for today's webinar will be the incorporation of continuous testing and validation into the life cycle through automation and AI. For any questions that you have, there is a QA button at the bottom of the screen for your webinar. Just post your questions there and our speakers will field those questions at the end of the presentation. We will get to as many as we can. This event will be recorded and we will share that video soon after we conclude the session. I hope you enjoy the discussion, and with that, without further ado, I'll pass it on to Rui to kick us off. Rui?
Thank you, Johnny. Good morning, good afternoon, good evening, everybody, depending where you are. It's a pleasure to have you on this webinar, and today I'm going to talk about how B-Yond is working closely with KEYSIGHT and bringing AI technology to the network lifecycle automation. As many of us realized, there's a lot going on in our industry. Things are changing, evolving, and there's an expectation that we become more agile. And this relates to being faster, delivering solutions to the market. So the technology lifecycle is accelerating. We have greenfield CSPs entering the industry using web-scale model and technologies rather than adopting more traditional infrastructure approaches. And we have the cloud companies, the usual suspects, getting more involved in this industry, either providing directly services to the CSPs or even acquiring network technology and bringing that into solutions and cooperation with CSPs. And 5G is the biggest transformation that is happening in our industry today. It brings, finally, software functions into the architecture. In the 5G core, we've seen already very mature solutions that are cloud native, and we see a lot of momentum in the radio access network with Open RAN, for instance. Now, software lifecycle is becoming critical. This is something that the IT side of the world already knows, and things like DevOps, CI/CD, continuous integration, continuous deployment are frameworks that have been adopted there and are starting to be adopted slowly in our industry. However, this process still remains pretty much focused on pre-production and test execution as we slowly transition to a software-based architecture. Now, there's a huge potential. So there's disruption and opportunity as we adopt these new ways of delivering infrastructure and services. We can innovate much faster. We can co-innovate. There's the opportunity to go to market faster with new services, enable new applications and new devices. IoT is a big example of things coming into our industry, and it unleashes the ecosystem of value-added partners. Now, all this sounds good, but software and the transition towards software brings additional challenges. And we believe that it's through continuous testing and validation that we're going to ensure the benefits of the transformation towards software. So how do we bring this test and validation together? So taking a step back, today, many of these activities remain essentially manual work. It's based on either repetitive tasks done by engineers or more skilled tasks performed by subject matter experts when it comes to analyzing and troubleshooting the results of tests. What we're doing as B-Yond and Keysight is we are bringing the automation and machine learning and the trained machine learning AI models into the process so that we can optimize and accelerate. First thing we're doing is we're standardizing the automation process with machine learning. So we're using machine learning capabilities to enhance the process associated with testing and analysis of the tests. As I mentioned, being a human-based task, it usually creates unaligned outcomes of some of those tests, analysis, and results. So a different engineer might classify or label a certain test result in a way than another engineer. And then you continue having a fragmentation of information. So we're using machine learning to standardize and bring that process together. And we introduce also machine learning as a continuous improvement process. So the more we process and push through our technologies, the continuous growing number of tests, the better these algorithms become and the more efficient they become. When it comes to the analysis and troubleshooting time, this is usually when, this is where the engineers spend more time, and that's where also we have scarce resources to provide that capability. So if a test fails, an engineer needs to investigate why it failed, what's the root cause, and what you need to do to remediate. So instead of occupying the time of those engineers doing the analysis and troubleshooting, we're bringing AI to assist that. And the engineer then becomes part of what we call the validation. The engineer validates if the algorithms are providing the right analysis, the right root cause, and the right remediation. And this will provide a continuous reinforcement of that knowledge. And we're building what we call an IQ repository. Many people believe when building a 5G network that first they need to build a network and only afterwards they need to start testing. We don't agree with that approach. So as Keysight and B-Yond, we're already connected and we have our engineers working together so that we pre-train those models, that we pre-integrate with emulated environments, and we prepare the infrastructure so that we can immediately deploy at our customers, and you can start having value from testing validation as you build the network, as you build components of the network. Those assets that we're building, so those trained models, provide from a high level validation of services like connectivity, mobility, or voice services, down to the granularity of some of the components. So we can provide models, and they are pre-trained to test specific components like a PCRF function in a 5G core network. As we build these models and continue training, we're capturing the knowledge of the engineers, both our engineers, Keysight and B-Yond, as well as the engineers at our customers that can validate the results and can reinforce the models. This has a positive impact in terms of preventing the problems of talent churn. Many times people rely, or companies rely on certain engineers that move on to different functions, and then that knowledge is lost. Now we're capturing that knowledge on these AI models. And the learnings and validation that we're doing in the test environment, the lab environment, is now applicable to the production, because those trained models can process the data from a production network and produce the same results. And this is one of the other challenges that we currently see in the industry. When you look at the life cycle of a network, you have what we call the regression testing, usually happening in pre-production or in the lab environment. And this is done by a certain type of tools and people. When you move into the service validation, it's usually in the network. You have things like first office application, drive testing, or emulation of calls or events, and the testing in a subset of a network. And it's usually done with different tools and different teams. And then you move into production, and then you have another team, an operations team, that is monitoring the network, and when things go wrong, they need to do troubleshooting, find the root causes, and perform regular health checks. These are usually siloed departments, and information is siloed. What we're doing as Keysight and beyond is we actually bring all the tools that cover from the lab environment all the way to the production network, and ensure that all of that information that is captured is available in all of the steps. And then not only you have a faster and more accurate resolution of problems in an operational network, but you're also capturing events in the live network that you're potentially not able to reproduce in the lab environment. And you're training those models. And once you go back to the lab, you already have more information, and you can accelerate the testing of new features. So how do you deliver this in your environment? This is how. You have the test execution step, and here this is where you have elements like a test lifecycle manager, which Keysight and Beyond are working together to provide this function. But we also realize that some of our CSPs are building this function themselves or working with system integrators, and we're doing it in an open way so that we can easily integrate. This is where we control the environment that is under test, either in production or pre-production, and that we trigger the necessary list of tests for the service that we want to test. From that step, you move on into test results and analyzing the test results. That's analysis and troubleshooting. This is where our platform, our product Agility, performs the analysis and uses our AI technology to identify the root causes and provide a remediation recommendation. And then on the action side, this is where we provide both the insights of the results of those testing, as well as the automation towards the systems or environments being tested, so that you can reconfigure the systems based on a remediation that has been predicted by our platform. Now, this, from an end-to-end perspective, can start being more controlled and validated through engineers, and as they gain confidence that the models are as accurate as they can be, you can start then making it a closed loop automation process. Now, this is where Keysight and Beyond excel in this industry. We're not waiting for those networks to be ready to integrate our products. We're working together. We're building the integration of our products in the sense of standardizing the format of the information that we need to process, so that we avoid having to process and parse too much information. We're defining which tests need to be executed, and we're pre-training or using Keysight capabilities to pre-train models. So when we integrate ourselves in a CSP environment for a 5G test event, we're already prepared to provide value from day one, although there's still the capability of continuously enhance the models through reinforcement learning based on the specifics of the customer that we're testing. So how, from Beyond perspective, how do we deliver Agility? So Agility is a product that we deliver on top of our platform that we call Infinity. So this is a cloud-native microservices platform. It runs on any cloud environment. We can run it from the Beyond cloud, or we can run it on a private cloud or even on on-prem infrastructure of our customers. So we really make it as flexible and modular in the way that you can adapt to the evolution of your cloud infrastructure. We use our patent pending intelligent element framework that enables the cooperation between various machine learning models and algorithms that provide the optimal result for the problem that we're trying to solve here. I mentioned before the IQ repository. So we're building continuously models, training models for a variety of different services. We're building data ingestion pipelines for a variety of different interfaces. And we're using programmable data parsers as a way to ensure that we can connect to any format or any vendor that is providing data to our platform. In summary, with continuous testing, continuous validation, Keysight and B-Yond today can provide a reduction of the test lifecycle. We're talking about hours, or in some cases days, and we're bringing this to minutes. We can increase, and we've proven that with a number of customers, that we can increase the testing capacity by 10 times. This is one of the current challenges that we see our customers. They have a limited ability of doing testing, and they tend to reduce the number of testing. If you're moving towards 5G, you'll see that it's actually about increasing the capacity of testing and being able to test not 1 or 2 releases a year of a certain component or infrastructure, but multiple releases a month of different components that need to integrate. And you can also achieve this by reducing your cost. We're using AI-driven technology and root cause analysis that eliminates the impact of talent churn. So we're capturing the knowledge of your engineers, and every time the models evolve and are reinforced, they become more accurate and granular in terms of identifying problems. This is applicable to pre-production and production, and it's easy integration through a SaaS model. And with that, I pass on to Jeff to give us a bit more details on the Keysight components that we're working together.
Thanks, Rui. I'm really excited to join B-Yond as we go through this journey together. Now, there's 2 messages or themes I would like to get across to you today, and that Keysight is edge to core, and Keysight is complete network lifecycle. So Keysight's test portfolio covers device testing, RAN testing, core testing, which includes the front haul transport and backhaul transport. We've been working with B-Yond on device testing and 4G core testing, some 5G core testing, and we've been preparing for the O-RAN testing as our customers start moving into O-RAN. Keysight provides insight across the entire network lifecycle, from the pre-production, as Rui has been mentioning, in the labs and network engineering, to deployment and to field operations. And this is where B-Yond and Keysight are working together to extend across the entire network lifecycle and really improve the analysis in the production network. It's one thing for us to provide the tests to create the faults and analytics that have to be analyzed, but we really need B-Yond to help in accelerating the analytics, because our customers really don't see the benefits until they have the results of our test case and the remediation. And that's where B-Yond really brings to the party. So now let's take a look at Keysight in the design phase, which is in the labs, but we also can extend beyond the labs. And again, as I said, we'd like to get that theme across to our service provider customers. It all starts with benchmarking the NFV infrastructure, and Keysight's solution is CloudPeak. CloudPeak has market-leading traffic generators. It has VM activation and termination tests, multiple VNFs for workload simulation. It includes noisy neighbor tests, and has open source tools for compute, storage, and memory. All right, so we now have the infrastructure benchmarked, and now it's time to test the actual core of the 5G network. So the 5G core is going to shift to the cloud, and independent scaling. It's going to bring new concepts and protocols in the service-based architecture. It's going to significantly increase the number of subscribers through massive machine type communications and IoT. It's going to require much more bandwidth, reduced latency for real-time applications. It's going to bring the computing and applications to the mobile edge core, and this will also be delivered with network slicing capabilities. Keysight's solution for core testing is called LOADCORE. It's cloud-native architecture, has elastic scaling, a new traffic engine for combination of realism and breadth of applications and securities. It has ease of use with the web UI and automation capabilities through REST APIs. LOADCORE has multiple use cases and test topologies. And this is really where Keysight and B-Yond excel. So Keysight can provide a whole host of use cases to train the B-Yond models so they can build that IQ repository. LOADCORE is a full core simulation tool. It can simulate the entire core network. Each individual node is distinctly activated. It provides end-to-end call coordination simulation and all procedures being exposed in all interfaces. It's useful for probe and analytics tools as they are training their models for when they have to provide analytics for the production network, and it's very high performance. It is this capability of LOADCORE providing all the different interfaces and exposing everything that really benefits B-Yond tool in learning the processes that they need to learn. Okay, LOADCORE has the ability to define the DUT as a single node or multiple nodes. It has the ability to deploy and simulate all the 5G nodes as we discussed, and an ability to simulate a call end-to-end in the network. In this example here, you'll see that the device under test in black is the AMF and the SMF, and then the simulated nodes are the nodes in the white. The strength behind the LOADCORE is the agents. So once we define the test that needs to be done, lightweight agents are then deployed into the network to simulate the network and whatever call simulation is required for the tests that we're applying. Let's look at a couple of the 5G use cases. The first one is a control plane use case of the AMF and the SMF. Of course, the AMF and SMF will be wrapped around with the SBA architecture that we need. It's coordinated the simulation of the N1, N2, N3, and all the rest of the SBA protocols. And it's deploying all nodes as individual entities. There's no topology hiding. And again, very important to help with the analytics and the training of the IQ repository. Next use case is a control and user plane test case where we're testing the SMF and the UPF. Again, it's focused on the functionality and capacity testing. We're going to validate the SMF and UPF are performing the QoS enforcements and the QoS detective support for the user plane validation. Another example is surrounding the PCF. And this was an actual use case that we had deployed for B-Yond and Keysight at a telecom customer in Europe. It was focused on the SBA node function testing of the HTTP2. It had individual validation of the protocols for PCF, UDM, AUCF, and NRF. It performed thousands of TCP connections towards the device under test. And we also did functional and negative test casings for impairment. In the case where the PCRF is brought in from a 4G network, we also add diameter flows. LOADCORE has REST APIs for integration in the network, as Rui mentioned, about integrating into the test network and test validation. It's very flexible design and technology. It's automation ready from day one. It has an embedded user guide, and it allows interaction with the UI in real time. So now that we talked about the pre-deployment, now we move into the validation and the health checks for the operational network. And this is where we find that service providers find it very helpful for them. They have all the analysis or all the faults generated from the test cases. Now we bring it to the production network and fine-tune the models even more and show them what is going on the network before their customers or their end users see any faults. And we do this with automation from B-Yond, as they really significantly reduce that analysis time for the engineers. Again, we're extending the test into the production network for many different aspects, for the NFV performance benchmarking, service birth certificates, real-time SLA validation, transport validation, secure ops validation, the ORAN validation, the automated root cause analysis that Rudy has been talking to you about, device benchmarking and training of the reliable data, and providing real-time data correlation and real-time distribution data acquisition. This is done with LOADCORE, as I explained before, with its agents. Instead of being downloaded into the test environment, these lightweight agents will now be downloaded and executed in the production network. As we move into the production network, we're going to move from being PCAP related in the training models to using live streaming traffic. And Keysight has the visibility fabric to correlate and bring this data into B-Yond, as well as the virtual probes and the metadata collectors that will be available in the 5G networks. So this is how Keysight and B-Yond is the only solution to be able to provide insight from research to the labs to deployment and into production network. Again, thank you, and let us accelerate your 5G networks together. Now we'll move on to questions and answers, and I will turn it back over to Johnny. Thank you.
Thank you, Jeff. Thank you, Rui. As Jeff mentioned, there's a QA button at the bottom. Please post any questions you have there, and we'll get to them in a minute. I do have a couple of quick questions for you, Jeff and Rui. Actually, as I was listening to this, one key thing you mentioned is about the readiness of the 5G network in order for operators to start testing and essentially certifying and evaluating their core for production. Help maybe elaborate a little bit on that point. Do operators have to wait until their 5G core is fully ready before something like this can be implemented?
No, they can start right away. B-Yond and Keysight have started. We're doing these pre-production in our lab, so let's call that pre-production, and then we can easily move into the labs. I think it would be a mistake to wait until your network is deployed live to start doing these training models. I find that about 80% of the work can be done in the labs before you even get to your production network.
Yeah, to add from my side, Johnny, when it comes to AI and machine learning, and as the name says, machine learning requires learning. There's a training period. Now, what we're doing is, in our joint labs, is we're pre-training a number of models for the 5G infrastructure. And that means that when we engage with our customers, even as they build their network, they can immediately start testing their infrastructure because we bring those trained models or pre-trained models. There's a continuous training that happens with these algorithms. So there's always a certain variation or different tests that our different customers want to start performing or to perform, but they can always start with the basics testings and the standard tests that we've already pre-trained our models. So there's value to actually bring automation, this test automation, as they start building their infrastructure.
That's an excellent point. I mean, the title of the webinar is Accelerating 5G, and this is a key point, I guess, to take away, which is the preparation and the testing can start beforehand. And we got a question actually that ties to this point here for you, Rui. How big the data lake will need to be in order to be able to handle so much 5G information for ML modeling? And I think what you're saying is, on a continuous basis, it doesn't have to be a big retained database, because what we're doing is we're preparing the models early on through the partnership with Keysight by generating and simulating all of the necessary data to have models that are ready prior to necessarily deploying the full 5G network, et cetera, correct?
Yeah, that's correct. And also, we are ingesting data. So I mentioned about ingesting data and parsing. So obviously, we can collect this data from a data lake that has a lot of information. But when it comes to train the model, there's actually a defined number of data points that are relevant for each of the models. So we train various models that can cooperate with each other. So these are processes that can be done in parallel, which means that we're ingesting less data. And through the cooperation with Keysight, we actually eliminate much of that ingestion and parsing. So we're just collecting the right amount of data that we need to train those models. And this is a good question, because this is one of the key topics about AI and machine learning, which is ingesting data and cleaning up the data. AI doesn't work well with unclean data. So a dirty input generates a dirty output. And the fact that we're working with Keysight to actually work with that clean data from the beginning reduces the amount of data that we need to process. And by doing it in our labs, we're already preparing it, and it doesn't really require a lot more when we install at the customer premises.
Yes, Rui, that's exactly right. And that's where Keysight's visibility fabric comes in, as we train that model by taking and cleaning up that data for good ingestion into your network.
Yeah, actually, to that point, Jeff, I have a question here, which is how are the probe and metadata collections? How does the probe and metadata data collection work, and where is this data kept? I guess maybe you can touch on how the data is captured, and Rui, maybe we can talk a little bit about how that data is used within the B-Yond platform.
Sure. So from a 5G visibility fabric, that data is going to be collected at the containers itself. And there's two different methods of collecting that data, either in a service mesh architecture, which we're going to see mostly be contained, or you can capture that data in a sidecar within the container itself. And then we provide that data into our packet brokers to correlate the data to provide to the data lake. Now, most of the data probably will be retained by the nodes themselves, as storage space is clearly not as much of an issue as it was years ago. So they'll probably store more of the information at the nodes themselves. But then when the metadata is correlated and produced, and then that will be put into the data lake for faster acquisition by the probes and B-Yond tools.
Rui, do you want to touch as well on how that data gets consumed and processed by the B-Yond platform?
Yeah, so and as I mentioned, we have different options to deploy our joint solution. So when we go fully integrated, we can consume the data directly. And we're looking at, when you talk about 5G and the amount of data 5G produces, we want to consume that data in real time. So typically we use technologies like Kafka, streaming of data, and we process that data as it's streamed. Our algorithms do not require data to be retained. So we're not replacing a data lake, but we can also process that data and collect that data from a data lake. So it can be that there's a specific deployment where Keysight is providing the data to the data lake directly, and then we're consuming it from there. So we're flexible. And as I mentioned, so data management and the flexibility on how to ingest and parse that data is key for any AI platform.
Makes sense. One more question. I believe this is, maybe we'll start with you, Jeff. How can the network operators de-risk their security and authentication and network service impact when they are considering continuous testing and continuous validation of production network?
Yeah, that's a very interesting question. As we move into security, most of the security tools are going to adopt the same platform or architecture, let's say, and download security agents into the network to constantly test for the security breaches that are going into the network and how the network is resilient to security. And we can use the AI ML models of B-Yond to then go ahead and look at, hey, we're seeing something going on here, and they have these tolerance levels, and then be able to predict, hey, there's a security breach about to happen, or there's something going on that we think maybe a security breach has already happened. So we do see the AI ML being extended into the security arena also.
I got a couple of questions on the models here. Rui, what kind of machine learning are we using? Is it supervised, unsupervised, deep learning? And how is the cloud architecture dealing with the large data? Is it real time, or how do we capture the test information as well?
Yeah, so those are all good questions. And AI is still an area which is evolving. So we're continuously working on finding out and trying what are the best methodologies and the best technologies available that we can use to provide the outcome that we want. We have a lot of discussions and debates with some of our customers about supervised versus unsupervised. And for instance, today, we are using supervised learning for agility because through many experiments, we realized that we achieve much higher accuracy and faster time to build a model and maintain a model. But we continue working in the background in terms of looking at how we can better use the various technologies as they evolve. So it's basically, in summary, what I'm saying is that this is a continuous development happening. We as a company delivering an AI platform, we're continuously looking for the best technologies that we can use that both provide the most accurate results in the least time with the minimum compute power. So which I believe there's also one of those questions is how much it takes to consume and process all of that data. And that is key. So there's many different ways of processing data and running AI algorithms on that data, but they could consume more cloud infrastructure and cost more than the benefit it brings. So this is part of our, let's say, core business, and this is where we continuously improve and optimize our platform.
Thank you. I mean, yeah, AI is about solving problems, right? And all of the models and all of the systems that exist out there are just tools to get there. And there's always better tools, and there's always better processes, and it's a continuously evolving. I mean, just like the models, we're learning as well, and we continue to improve on those for sure. I've got one more question here. How does your solution integrate with best of breed machine learning algorithms? Again, tying to the point that we mentioned. And if the operator themselves have some in-house machine learning assets, for example, using TensorFlow, would those be able to be ported onto our platform, or would they not be able to reuse those?
Yeah, definitely. So I mentioned our platform called Infinity. So we build it as an open platform, and that means that we have components that we're exposing, and they can be used by partners or our customers so that they build on top of it. We have an SDK, so we provide an SDK and we provide the guidance for customer or partners to actually bring their own models and run on top of our platform. So this is one of the areas. And as I mentioned, we are building our own models. We have the data science capabilities, so that's important for customers that want those pre-trained. We can co-innovate or co-develop models with our customers, or we can just, as I mentioned, open up our platform and help our customers build their own models on top of it.
Yeah, again, going back to the point you mentioned, the idea is here from both companies. I mean, the partnership here, the takeaway for me has been there's the benefit that the testing, the continuous testing provides, and especially within a 5G ecosystem, and the benefits that the AI bring in, coming together, produce pre-trained assets that can accelerate that life cycle, right? And these were all the questions that we got in here. Please keep them coming in. Again, we can answer afterwards, but just any closing remarks, Jeff and Rui, I'll start with you, Jeff. Anything you want to leave everyone here with as a closing statement?
Again, it's an exciting time to be doing 5G, as 5G is bringing in the complexity and bringing much more complexity to the networks. You know, we're going to have to apply AI ML, as the human efforts are just not going to be able to keep up with all the complexities that 5G is going to throw at us. And so we're excited to be able to provide all those test cases and throw all those errors over to B-Yond, so that you can process and analyze and help us accelerate the 5G deployments.
Yeah, also I reinforce that message. So as I started opening this this webinar, we are going through a transformation. Either we like it or not, or prepared or not. And there's no way that we can drive this transformation doing things in the same way and using the same old tools. So this is the time to really partner and work with the people that have the expertise. So I consider Keysight and B-Yond two of those companies that see where the world is going and are working very hard today to help the service providers build their 5G networks. It's an exciting world out there with 5G. It's also a scary world with the transition to software, but myself being an old hardware network person that evolved to software, cloud computing, edge computing, and now AI, I can guarantee you it's very exciting. I think this industry can do wonders to the world as we evolve and build these 5G capabilities.
Okay, Jeff, Rui, thank you very much. I hope everyone on here enjoyed this webinar. It was a pleasure. As we mentioned, we'll share the recording afterwards, and you saw our contact information. We're on LinkedIn. If anybody wants to touch base or has any more questions afterwards, please feel free to reach out. And have a great, wonderful rest of the day, and we'll be in touch. Bye-bye.
All right. Thank you, everyone.
Thank you. Goodbye.